Welcome to the continuation of Chapter 4, Overview Part 4. We're going to do Section 4.5, Concentration of Solutions. The topics we're going to cover today is what is concentration, a way to measure it, which is called molarity, how to make a solution, and then if you want to dilute that solution, how you go about doing that. So what is molarity? Well, when you have a solution, the amount of solute that you dissolve in it is important when doing calculations. And the amount of solute dissolved in a solution is called the concentration. Molarity is just one way of measuring it. And the equation for molarity is moles of solute divided by volume of solution. And just remember, solute is the substance that you're dissolving. This M here we abbreviate as a molar. So molarity can also be used as a conversion factor between moles and liters. Okay. So let's do a couple sample problems here. It says, what are the molar concentrations of each of the ions present in 0.025 molar aqueous solution of calcium nitrate? So the first thing we're going to do is write down the formula for calcium nitrate. It said it's aqueous. So when you add it to water, it will dissociate into calcium ions plus 2 nitrate ions. Why 2? Well, you see there's a 2 here. So you could look at this as a balanced equation. So now what are we starting with? 0.025 molar, which just means 0.025 moles over liters. And we want, and this is of calcium nitrate. But we want to know for each ion. So we have to do it once for calcium ion and nitrate ion. So what is the mole ratio for calcium nitrate? So if I had 1 mole of calcium nitrate, then I am producing 1 mole of calcium ions from my balanced equation. So then when I calculate it, so the concentration of my calcium ion would be 0.25 molar calcium ion. Now I'm going to do the exact same thing, but this time we're going to do it for nitrate. And you might have been quick about it and looking at it and realized that nitrate is double the amount because the mole ratio here is 2, because there's a 2 here and a 1 here, right? So not only is molarity a way of measuring concentration, but you could also use it in stoichiometry to calculate the concentrations of other things in your reaction. Let's look at the second example. How many grams of sodium hydroxide are required to make 100 milliliters of a 0.25 molar solution? So they are giving us 100 milliliters. Now, if you remember correctly, molarity is moles of solute over liters of solution. And this is in milliliters. So I would convert this to liters right off the bat. And remember, there are 1,000 milliliters in 1 liter. So that means that 100 milliliters is equal to 0.1 liters. There are all these zeros here because of significant figures. So our given is 0.1000 liters. Now remember, I'm looking for grams of sodium hydroxide. So first I have to use the molarity to get the moles. So my molarity is 0.250 moles per 1 liter. So you see my liters cancel out and I end up with moles of sodium hydroxide. But I don't want moles of sodium hydroxide. I want grams, so I have to use the molar mass. Which when you use the periodic table, you add up the mass of sodium, oxygen, and hydrogen, you're going to get 40. So then when you type this in your calculator, it's 0.1 times 0.25 divided by 1 times 40, you're going to end up getting 1 gram of sodium hydroxide. So what does this mean? If I want to make a 0.25 molar solution, I need to add 1 gram of sodium hydroxide to 100 milliliters of water, if it's aqueous solution. How do you actually mix a solution? When you're making a solution, the first thing you want to do is mass out the solute. Mass out your solute. And then you will have to take that mass and calculate it, the number of moles. Because if you want to know the molarity, it's in moles, right? So you mass it out, then you add the solute into your volumetric flask. This here is a volumetric flask. A volumetric flask has only one measurement on it. It'll have just one line up here. So this particular flask is a 250 milliliter flask. So that's all it can measure is 250 milliliters. So this is very accurate. So you add the powder, then you add the solvent, which in this case is water. Okay, why do you add the powder first? Because the powder might actually change the volume a little bit, right? So you add the water to it, and then it all dissolves. You add it up to the line, and then you have your the proper concentration of your solution. So volumetric flasks are used to make solutions quite commonly because they are very accurate with just that one line on there. Once you have your concentrated solution, you might want to dilute it, okay? So a solution can be diluted by only adding solvent. When you dilute something, you lower the concentration, but the moles stay the same. Because you have a larger volume of solution, the concentration is now lower, but the moles stay the same. So the equation for calculating a dilution is you take the molarity of the concentrated times the volume of concentrated, and that's just going to give you the moles of the concentrated, right? And you set that equal to the molarity of the diluted times the volume of diluted. And remember, if you take your molarity times your volume, as long as your volume is in liters, you will get moles. So let's do an example. How many milliliters of 3.0 molar sulfuric acid are needed to make 450 milliliters of 0.1 molar sulfuric acid solution? So, what is our equation? Our equation is molarity of the concentrated times the volume of the concentrated equals molarity of the diluted times the volume of the diluted. So let's see, what is the molarity of our concentrated? It is 3.0 molar. The volume of our concentrated we don't know. The molarity of our diluted is 0.10 molar. And the volume of our diluted is 450 milliliters. So now I can plug everything in. So the volume of my concentrated would just be 0. Well, 0.10 times 450 divided by 3, and you will get 15 milliliters. So what did we solve for? We need 15 milliliters of 3 molar sulfuric acid. The second part says, what volume of water will you need to add to that? Well, remember, the total volume that we want is equal to 450 milliliters. And 15 milliliters of that is the sulfuric acid solution. So you just do 450 milliliters minus 15. And that means you need 435 milliliters of water to make a 0.1 diluted solution. So let's summarize what we covered today. Molarity is one way to measure concentration, and molarity is defined as the moles of your solute divided by your liters of your solution. Molarity and mole ratios can be used for calculations. And in dilutions, your moles are constant, but the volume changes. And we could use this equation here where C stands for concentrated and D stands for dilute. Okay, if you have any questions, let me know.